Hello everybody and welcome to today's lesson on graphing secant and cosecant functions. So our objectives are we will graph secant and cosecant functions, and we will do that using the sine and cosine functions that we already know much better, and we will also state the domain and range of secant and cosecant functions. So let's get started. First we're going to have a look at the cosecant function, and let's remember that the cosecant is the reciprocal of the sine. So y is equal to cosecant of x is the same as saying y is equal to 1 over the sine of x. And the best way to start graphing cosecant and secant functions is looking at their reciprocal functions, and in this case that's the sine function. Also, let's remember that the pattern for the sine function is O holo. And with that being said, we can now go ahead and sketch our sine function. First, as always, we're going to label our axes. 4 boxes is pi, 8 boxes is 2 pi, 12 boxes is 3 pi, negative pi, and up 1, 2, down negative 1, negative 2. Our sine O holo starts at 0, then it goes to the high, back to 0, to the low, and back to 0. And I'm only going to do this with a dashed line because that's not really what we're trying to graph here, but it's just a helper for us. And now looking at the sine function, let's think about what happens to our 5 key values if we take the reciprocal of those. First we have 0. And if we took the reciprocal of 0, 1 over 0, we can't divide by 0, then we would actually have an asymptote. So here would be an asymptote. And that would be the same every time the sine function hits 0. So every pi we have a asymptote. Okay, so much for that. Now let's think about our other points. When the sine reaches positive 1, 1 divided by 1, then the cosecant would have that exact same value. And if the sine goes to negative 1, 1 over negative 1 would also be negative 1, so the cosecant would be at that same value as well. So now we already have 5 key values for the cosecant. Let's put those into a table of values. Here's our table of values. And now let's think about what will happen to the cosecant for values that are between these key values. And again, we're going to take a look at the sine to help us out here. The sine goes from 1 and going towards 0, it gets smaller and smaller and smaller. So if we take the reciprocal of those values, as the values get smaller, 1 over those values gets larger and larger and larger. And as we know, it can't reach 0, so that's why we have the asymptote. That means that our cosecant curve will go up and get closer and closer to the asymptote. And the same will also happen to the other side towards the other asymptote. Let's look at our other key value, negative 1. Now here the values for the sine get closer and closer to 0 also, but they have a negative sign. So 1 over that smaller and smaller value, but with a negative sign, will make our cosecant values go towards negative infinity as they approach our asymptote. And this is what the graph of the parent cosecant function looks like. Just like the sine function, it will continue periodically. And be clear that the cosecant function is only the red part that you see in the coordinate plane here. The blue part was the sine function we just drew in there to help us out. It's not part of the cosecant function. Now let's talk about the domain and range of the cosecant function. Since we have all those asymptotes, the domain is not all real numbers, but the domain is x such that x cannot be equal to. And when do those asymptotes appear? They appear at pi, and that at every following pi. So our period here is pi k. What about our range? We go all the way to negative infinity, and from negative infinity we come up and we get to -1, but no further than that. That is part of the range. -1 is part of this, so we use the brackets here. But we have another part of the range, so we have to use our union symbol. The other part of the range starts at +1 and goes all the way to positive infinity. So we have a range that consists of two sections here. So this is what the parent cosecant function looks like. And be clear that it's only the red part that really is the cosecant function. The blue part that we put in here as a dashed line was our sine function that helped us out. That's not part of the cosecant function. It's only those red curves that continue periodically towards the left and the right, just as the sine does. Also note that the parent cosecant function has no x-intercepts and no y-intercepts. And now let's move on to the secant function. Now the secant, as we know, is the reciprocal of the cosine. So y is equal to the secant of x is the same as saying y is equal to 1 over the cosine of x. And similarly to what we did before, we're also going to use our cosine function to help us out graphing the secant. For our cosine, we use the mnemonic holo to graph it. First, we're labeling our axes, pi, 2 pi, 3 pi, and so on. And now we're ready to graph. Remember, holo, we start at our highest point, which is +1. Then we go to 0, go down to -1 at pi, go back to 0, and back to 1 at 2 pi when our period is completed. I'm going to do this as a dashed line again. This is only to help us for our secant. And now let's look at our 5 critical values, similarly to what we did before, and think about what does that mean for our secant function. The cosine also has values where it reaches 0, and again, if we take 1 over that value, 1 over 0, we get an undefined value, so we will also have some asymptotes here, and these asymptotes will appear every time the cosine function is 0, and they will repeat periodically and will be pi units apart. Where the cosine is +1, that will mean that the secant is also +1, and where the cosine is -1, that will mean that the secant is also -1. And the behavior between those key values is also similar to that of the cosecant function. As the values of the cosine go towards 0, the values of the secant go towards -infinity in this case, +infinity as the cosine approaches 0 from the positive side. I'm drawing 2 more here so we can see the repetitive periodic pattern. And to make it clear, I'm also going to draw 2 more asymptotes here. Let's look at our domain and range. The domain will also be broken by our asymptotes. So x such that x is not equal to, let's take our first positive asymptote. That happens at pi over 2. And then it happens at a distance of pi each time, so plus pi k. And the range starts at -infinity and goes all the way to -1. but there's another part that starts at +1 and goes to positive infinity. And here is our secant function now. Again, it's only the orange part this time, not the green part. And as you can see, it looks very similar to the cosecant function. And just like the cosine is shifted horizontally from the sine, the secant is shifted horizontally from the cosecant, and precisely by pi/2 units. So much for our two parent functions. And now go ahead and watch the second part of this tutorial where we'll talk about graphing some examples.